Right, hi everybody. All right, we're gonna move on to this. Here we go. All right, now I gotta move this. Doink. All right, so hopefully you got something along these lines. Yoink. All right, so definitely have a slant asymptotes somewhere. So I have y equals x minus 3, so you should graph that, know how to graph a line. I think your graph has to look exactly like mine, to be honest. Because we have an infinite discontinuity at x equals 2, we need to know that that's a vertical asymptote. So infinite discontinuity is vertical asymptote. Removable, like I told you, is like a pothole. It's a hole in the graph. So that's what that means. Intercepts, yes, and then asymptotic behavior, we almost don't even need that when we get, unless, except, no, actually, we don't really need that. Now I'm trying to think. Yeah, it's got to be there. It couldn't be the graph in here because of the x-intercepts. All right, we couldn't have it here. All right, great. We could. What just happened? What is going on? I love you, computer. I love you. Love, 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 love. It couldn't be here because of the x-intercepts. All right, so that's why we got to have that graph where it's at, connecting those points. How many people got that right? Raise your hand. All right. I don't think there's any other options. It's got to be. Then you get another oblique, and then we have a hole. So we must draw the hole, draw it as a big open dot. That is an interruption in the domain. As a matter of fact, we're going to do that today. So just as we're looking at this, we could actually talk about domain and range right now. But take a minute to look at that. How many people got that right? All right, it's got to be pretty much that drawing in there. Vertical asymptote x equals -2. Oblique goes through the origin with that negative slope. X-intercept -1, 0. Now I guess you could go above that x-intercept and come down. I just kind of thought that was the easiest way to draw it. And then, yeah, I guess you kind of have to have that point up there. It doesn't really, oh, f of -3 equals 6. Good. I missed that first part. So that proves that this is up here then. So, yeah, so that's why that has to be up there because of that one. I was trying to see what determination told me that it's not there. And it's that one point there. So that's good. All right. All right. So hopefully you did all right on that. All right. I just said domain and range. Let's go ahead and put that down real quick. Now, what does it mean to be domain? It's what you can plug in. I'm going to give you two different ways that are mathematically valid, but also the AP exam goes back and forth. They're not only interval notation. They go back and forth between interval notation and I guess what I call algebra 2 notation, but you guys don't know what algebra 2 is because it doesn't exist at Lockport because we have math 2 honors. The rest of the state of Illinois has algebra 2. But anyway, X line, a little bitter about that. X line, and then what can't X equal? Well, X cannot equal the asymptote. Whisper, whisper. Always hear that voice in first hour. -2 and the whole. The whole is located at 0, comma, so X cannot actually equal 0. Because the whole means 0 over 0 is the output, and we already determined 0 over 0 is undefined. I want to make sure I'm not making any other mistakes. Nope, those are only two interruptions. Unfortunately, I always say this, for interval notation, it's a little bit more annoying. And I always kind of write it like this. It's all real numbers, so it's every single real number. And by the way, back up here, that's what a not equal to sign means. It means everything but these two numbers. That's why it's a more convenient way of writing it. For interval notation, we have to exclude -2, and we have to, wrong. And then exclude 0. Unions are put in there. Almost gave myself enough space, got to squeeze that in there. So it's a little bit longer. Imagine if you have 3 different interruptions, then this would be a lot longer, excluding 3 different answers. The range is a little bit tougher. Input say it. Now, I don't know how else to draw this, but this y coordinate exists, this y coordinate exists, this one does not here, but it does there. So actually that is not a range interruption. All right, so do understand that hole, the y value is covered by another point on the graph, so not an interruption. But then weirdly, not weirdly, whatever you want to call it, the range stops here, and then we have this big gap in y's. I really don't understand how students don't understand range when range is y. And all I have to do is look at the picture and see what y's exist. All right, so the hole is a little tricky, but maybe not so much. And I really can only, I guess I could do this in, I don't know what I'm thinking. And this one's a little bit tougher, this notation. Because really what I have for y is everything less than or equal. And by the way, this is like a bar. This reads like x such that. And then right after this bar, this is what x behaves like. So that's what x bar means in this, what I guess I'm calling algebra 2 notation. All right, and then what is happening with y? Well, it looks like we have all y's less than or equal to 0. And actually the word you're supposed to use for this notation is or. It could be on the other side. And then I get, and I guess I'd have to know more about, but compared to the picture I've drawn here, 1, 2, 3, 4, 5, 6, I decided, because this was cryptic language, sorry, that's a mistake, y greater than or equal to 6. I just made that the lowest point of that curve. Again, this was a weird question where we had to make a sketch. Answers will vary, so your range and domain, not your domain, the range may vary. All right, and then how do you do that in interval notation? You'll probably be easier with this. Negative infinity to 0. 0 is one of the outputs, the way I drew my drawing, and then 6 is one of my y values to infinity. Okay, so range, you have to look at the picture and see what y's are covered. Don't know why students have issues with range, because that's all I got to do. All right, I got rid of 1 because of time, and we just got to get going. All right, in your notes, I gave you A through F that you can write next to, correct? All right, but unfortunately, look at your homework. If I would have got here a little earlier, I would have changed your homework in the same format. Instead, what I did is I tried to reduce your assignment. Is that okay? All right, so I crossed up 1s, but you do have to, on a separate sheet of paper, do your A through Fs, and then put the grid, put the graph on the grid. So separate sheet of paper, do your A through Fs in your work for it, and then go ahead and back to your paper and try to squeeze your graphs in there, okay? Losing my voice. Okay, that was great for the kids. All right, first thing you got to do always is factor. Okay, and then I wish I had my notes that had this. I guess I could see up here. But, got to be careful with 6 and 5. So what multiplies to -6 and adds to 5 negative is -6 and 1, not 2 and 3. 2 and 3 would be if it was +6 and -5. See, the difference between -6 and 1 is -5. That gives me that middle term. So people miss that up a lot, dealing with 6 and 5. All right, A, discontinuities. Okay, because of notes and time, I'll write this one out. Identify the discontinuities and what type. We only have vert asymptotes. And feel free to just say vert assy, and then it's at x equals 6 and x equals -1. I'm sorry, I'm trying to get my voice to not be cracking here. 6, and every single thing that you note, go to your grid and put it down. All right? I implore my A-Bers to do this, and actually we had a quiz and they were a little bit better. It was pretty decent to see. All right, write the equation of, okay, so that's A and B. There's a little bit of redundancy in this. I mean, if you just combine A and B and just say x equals 6 and x equals -1 for assy, you took care of B as well. All right, identify any holes. None. So C is out. Because I don't have canceling factors. This is a fun video. D, write the equation of an end behavior asymptote, horizontal or oblique. Well, that's kind of out of place because I'd have to determine what my horizontal asymptote is. Through the rules that I've already identified, everyone should know that it's y equals 0, right? The numerator's degree is 0, denominator is 2. So there is the horizontal asymptote. Y equals 0, draw it. And now, I mean, it's actually almost, we really should do D after I graph, but I could do it now because I know that horizontal asymptote controls the ends. All right, so I know I'm good. All right, X, Y, and Y intercepts. I really think you could have done this first. The X intercepts are the zeros of the numerator. So X ins, none. None. Y-intercepts, remember, you plug in 0 for X. So you plug in 0 for X. These become 0. This is what you're supposed to do with your and. 0 squared minus 5 times 0 on the bottom minus 6. You just get negative 6 on the bottom. So the y-intercept is 0 comma 1/3, negative 2 over 6. Go and graph that. All right, and this is going to be a little weird about determining where the graph is. All right, so F is going to graph, and then we're going to go back to D and do our interval notation. Okay, input, say it. All I need to know is what's the sign of my input / output. Because what I'm guaranteed is I have one of two things that could happen over here. It could either be this or this. It's one or the other, not both. And you will get major points off if you graph a non-function. So some of my A-Bers, when they graph this rational function, they had both curves. So, and this is a function that fails the vertical line test. So that's not even a function. So if you're ever graphing a rational function that fails the vertical line test, you're already wrong. All right, it's not possible. So what am I going to do? I'm going to input, well, I have this at -1, so I pick the smallest number, -2. And we're going to fast track this. What's -2 plugged in? What's -2 squared? 4. What's -2 times -5? 10. So what kind of number do I get on the bottom? A positive or a negative? Well, what's a negative over a positive? So I got a negative output when I plugged in -2. I'm somewhere down here. That means the whole graph is down here. And that's all you got to know. All right? Got it? Now, I do have an issue with the middle. All right? And then sometimes we allow you to have a graphing calculator. So if you want to do that tonight and alleviate your input output, go for it. Type it on your calculator screen, see what the picture looks like, and make it fit your data there. Really nice. No calculator copies. I'll tell you the calculator copiers. None of those dotted lines are graphed. The y-intercept's not noted. And then they just do this. And then they got this, and it looks like garbage. Absolute garbage. You know what I'm saying? So make sure if you go to the graphing calculator, you make a graph that fits your data. Did I make a mistake? I can't hear what you said. Did I do that? Yes, you're right. My bad, dogs. Never mind. Riff. Now, but I do know this. Look, there's this, and then I was a little worried that being -1/3, it didn't make sense to me because usually there is a little alternation between these graphs, like above, below, and above. But I have one question. Is there an x-intercept here, yes or no? No. So could this graph possibly cross the x-axis? Yes or no? No. So you know what the action has to be? It literally has to be this. Approaching that asymptote, hitting this y-intercept, and then coming back up. All right? And then let's see what time it is. 8:06. Really, I don't know why my voice was fine until now, like teaching. Okay. And then the last thing, input, say it. But where do you think it's going to be, above or below on the right side? Where do you think, above or below? It usually does alternate. There are rare cases, but just be like thinking it probably will be below. All right, so let's plug in a 7. It's going to be big. Well, not too bad. 7 plugged in is 7 is 49 minus 35. 7 times 5 minus 6. What kind of number is this? But what's a negative over a positive again, right? Negative. So all you need, yes, it's input output, but you're literally not finding like exact coordinates. You're assessing above or below the asymptotes. I don't think that's hard. And if you're fast with your calculations, it's faster than getting your graphing calculator out. Y equals fraction button, get it in there, change your window, hit graph. I think you'd be done by then. And I think it's faster. Did I make another mistake? Oh, yes. Well, when there's 2 vertical asymptotes, there's a graph to the left, middle, and right. So there's definitely going to be 3 parts. When there's 1 vertical asymptote, there's 2 parts, left and right. If there's 3 vertical asymptotes, I hope we don't do that to you. Then you have a whole bunch of parts because there's one in the middle, before, after. There's always a part that exists. All right. Okay. All right. Are you doing calisthenics over there? I thought you were like raising your hand and I see just like this. You okay? Okay, all right. I thought I had a question over there. I saw hands flying up in the air. All right, and then we could have done this if we know anything about limits. X goes to infinity, negative, let's say, 0. X goes to infinity, 0. What time we got over there? Okay, all right. Let's go to the next one. Okay, you know what? I did not on my notes, but I did on yours, didn't I? I was going to reprint these. On 7th hour, I'm going to use your notes so I can see these letters. I'm just going to do it. I don't care about the letters. All right, I know what I have to do. First thing is, and I usually go in this order. Well, you better do this. Factor. Okay, but then you should know something right away. What kind of asymptote do I have? Horizontal or slant? Horizontal or slant? Slant. So I don't care what the order is, A through F or however many there are. I'm going to go ahead and find the slant asymptote. First thing I have to find out though, do I have a hole? And I don't. That's why I need the factor. So the second thing is I'm going to find the slant asymptote real fast. I'm going to fast track this. Go ahead and put 0 for the constant, but we know we don't need this anyway. But just give yourself a space so you know how to complete synthetic division when there's a missing term somewhere. Bring down to 3. 1 times 3 is 3. And that's it. So the slant asymptote, wherever letter that belongs, that is y equals 3x plus 6. Oh boy, I don't think we have a big enough graph here. 1, 2, 3, 4, 5, 6. And then I'm going to go down a 3 and over 1. This is a positive. Down 3 and over 1. Okay, so the graph is going to be off the grid a little bit. And then, of course, x equals 1. That's right here. So we have a vertical asymptote at x equals 1. Feel free to label it. I don't have time. Okay, and that's what I mean. We are off the grid a little bit. I probably could have messed with my scale. You can always mess with your scale a little bit, but I'm worried I'm going to have part of my curve in this little sliver in there, in that little slot. Okay, so we got to make sure we see some other information to make sure what we have here. All right. So the zeros of the numerator are the x-intercepts. So I have x-intercepts at 0, 0, which is also a y-intercept. So now you can say to yourself, I don't have to look at a y-intercept. If 0, 0 is an x-intercept, it's also a y. And then negative 1, comma 0. All right, so 0, 0 and negative 1, 0. This tells me everything. This tells me everything. I know exactly how to graph this now. There's no problems whatsoever. All right, what else do I usually have to find? I don't have a y-intercept. I have a slant asymptote. I have the vertical asymptotes. We could do our limits after. I really do want to make this as quick as possible. Anything else? Let's see. Well, I guess I better look at the list. Identify holes. There aren't any. Equation of behaviors. I'll just verbalize that. X and Y intercepts. Graph the function. type of discontinuities, two vertical asymptotes. Yip yap 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 yip yip. Is that annoying? Because that's how annoying it is when I'm teaching and someone talks every single day when I'm teaching. Alrighty. Last thing. All right, what was I looking at here? Okay, the last graph. Boing. We know this is going to be up here because first hour, one student. We'll figure it out at some point. I think I'm going to sit him right here, just right in the front, just so we can make sure I can not have to talk over him. We are now on October 1st. Wait, it's October 2nd. I have a bill due tomorrow. I better remember that. Oh my goodness, I didn't realize it was coming up. If I don't pay that when I get charges. Yeah, there's no retakes. No, sure, you can pay it later for an extra charge. Costs money. Life lesson right in the middle of the notes. 2x, 1x. You have no idea how much you've been enabled by the American education system. Just wait till life happens. All right, so anyway, 2 times 3 is 6 plus, and then minus 1. Okay, right? Isn't that good factoring? Because you know why? I'm a good foiler. And then, I think you've heard that before. And then take out a 2x. Hey guys, do I have a hole? Yes, you do. You know what I choose to do? Like, I know I have a hole, so I'm going to find it right away. All right, I don't care A through F, wherever it lands. You do what you want. Basically, I'm not going to hold you to, lettering A through F. In your little scratch sheet of paper, just do your math to find what you think you need to find. There's no order to this. So it's not that important that you find one thing first before the other. Okay, so -3 is the naughty value. Do you understand? Oh, then domain and range. I could do one of the domain and ranges. This might be a good one because holes are a little bit, different. All right, and then I'm just going to do the math real quick. 2 times -3 is -6. Minus 1 is -7. Yeah, that does work. And then 2 times -3 is -6. Meaning I don't even have to reduce. I could go ahead and, cancel those negatives. So I'm going to go right to it. -3, 76, which is a little bit bigger. And then put that hole there and make sure the graph goes before and after that. It's going to continue through it. So you can count it as a nice little point to use to make your picture. Where is the graph at, above or below? Blah, 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 blah. Hey, what's my horizontal asymptote? What's my horizontal asymptote? Horizontal assy, what is it? Y equals what? Uh-oh, no one said anything first hour. 2/2. No one said a word. What's 2/2, everyone? 1. And then I'm going to draw that. All right, I see that. See that open dot right there? That means the graph will be above in that area. Okay? And then vertical asymptote is x equals 0. Okay? All right, I think I know what's going to shake out here. I think I know what's going to happen. And then one more thing, I do have an x-intercept at 1/2, x-intercept, int, I meant to do a dash and I did a colon there. Add 1 divided by 2, 0. Yep, that makes a lot of sense. I know exactly what this graph is. I don't have to go to my graphing calculator to see that picture. Okay, so we're going to go ahead and do this. Doink. And then it goes all the way up to this. And then because that x-intercept is there, proves that this graph is below. So easy. Most of the time, you don't even have to do an input-output. The x-intercepts, y-intercepts, shucks. What is the y-intercept? All right. Well, I have a vertical asymptote here. If I cover all these and plug in 0 for x, what is -3/0? Undefined. What does that mean about the y-intercept? Doesn't exist, and that's the vertical asymptote proves that. Okay? All right, and then you could do your limits as x goes to infinity and negative infinity and infinity. We're approaching 1. That's the answer to those limits. I don't have the time to write that. Okay, I do want to fast track this as I have 8 minutes. All right, is there a your turn? Did I skip 5? No, what did we do 5? Was that 5? Or was that 6? We did 5, we did 6. Okay, your turn. Do we really have time for your turn? No, let's just go ahead and do it. Or you know what? I'll freeze it. If you want to go ahead and do it, I'll just do this on the video. Freeze. So in class you can try to jump ahead of me. It's a race. You beat me. All right, let's go. All right, good foilers, good factors. Okay, those on the internet. This and this got to be that, right? And then that has got to be. So then I think I should put that there and then that there. Let's check it out. Oh yeah, I am a good foiler, which makes me a good factor. Okay. Middle term. Oh yeah, -1. Yep. Oh no. X minus 2. Oops. Don't say that out loud. Okay, you better be at this position. Is there a hole? Is there a hole? Yes. Okay, so they don't see this. I'm trying to have them do it. They're talking. Now he can yip yap. Oh, he's yip yapping away. You don't have a burner phone too, do you? No, because he had his phone too for a while. My ex-wife, remember the charlatan? But I did see her yesterday. She told the story about a bum, and she is just like me as a teacher. We don't tolerate anything. She doesn't tolerate anything for me, for me anyway. But anyway, that's a long story. She caught a kid with a burner phone yesterday, just yesterday. Oh, and that kid, he just moved into her class too, and this kid's driving me nuts. What the heck was that? AI is like talking to us. 2 times 2 is 4. 4 minus 1 is 3. And then 2 plus 2 is 4. Does anyone know what I just found? What did I just find? The hole. Okay, so you should know what the hole is. All right, and then I'm just going to go vertical. Vertical assy. It sounds like he's saying a naughty word. Asymptotes. Let's all grow up here, just like the teacher. Maturity. All right, and then horizontal asymptotes. Assy. Wait, that doesn't. Horiz assy. That sounds better. All right, y equals 2 over 1, which is 2. Okay. Oops, sorry. I'm not supposed to be verbalizing this because the kids out there are working. What time is it? And don't get me in trouble for ex-wife jokes. I got in trouble last year for saying some funny things, and hey, I don't think that's appropriate. I'm like, come on, give me a break. Anyway, I got that in the settlement. I got all the jokes. She doesn't get to tell any. All right, here we go. And then silence. They even know what 1/2 is? What's 1/2? What's 1/2? What's 1/2? What is that for the graph? The x-intercept. I was seeing see again that the kids in class can't see my work here. And then, oh, that's weird. Okay, what's -1/2? That's wild. The y-intercept. But don't write it like that. Write it as a coordinate. Okay, so they can't see the screen. I froze their screen. All right, and then I'm graphing these as I go. Okay, that makes a lot of sense. I know exactly what this graph is doing. So I'm going to go ahead and show the class what I have so far. Play. Okay, so that's what I have so far, right? Is that what you have? And you're probably, hopefully you beat me. You have the actual graph, right? Am I okay? Okay, well then this is what come on. How do you connect these? You go like this. I'm a little shaky here in my old age. All right, and then that goes to there. And then do I have an x-intercept here? Yes or no? Do I have an x-intercept there? Yes or no? No, so where's the graph? Above or below? Above. This ain't rocket science, man. This is easy. All right, you don't even have to go to the graphing calculator to have an idea of what's happening here. Did I have a hole? Oh no! Oh no! Oh no! Oh no! I gotta. Did I do another mistake? I'm getting a bunch of Mr. Samuelises. Two. It's positive. Oh, for the love of dog! Oh my goodness! What am I doing? I do this on purpose to see if you're paying attention. As far as you know. All right. So let's get this all over with. 2 comma 3/4. You're here. All right, and then the vertical asymptote. No, the vertical asymptote's at x equals -2. Yeah. Whoa, 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 whoa. Yeah, no, we're good because then that wouldn't have worked out. And then my y-intercept and x-intercept are still here and here. Yep. So no, that's right. That's right. I have my vertical at. You didn't factor right if you got x. Not x. My x equals -2. That's all I can say. All right, so I forgot the whole was the only thing that I forgot. All right, and then our limits for end behavior, we're approaching that horizontal asymptote at 2. So in the end here, limit, I'll write this one down since I skipped on some other ones and we'll end the movie. As x goes to negative infinity, we go to 2. As x goes to negative infinity, we go to 2. And then I guess I will do domain and range. Okay, and I'll throw that to the right. So what's the domain? Just your interruptions. Because of time, let's do the faster way. X cannot equal the asymptote, which is at -2, and the whole 2. So that means, and those are braces. That's a really bad try at writing a brace. Look at your keyboard. The brace is above the bracket on your keyboard, second brackets. All right, and then the range. The range is pretty easy on this one. We do have a hole though. So this range value is interrupted because it's not covered by any other part of the graph. All right, so I don't have that range value and I don't have this range value. The graph, yep. I love that group. All right, y such that y cannot equal, well, let's look at that y coordinate of the whole, which is 3/4, and then the y coordinate of the asymptote. Now, I will mention this. Sometimes the horizontal asymptote can be covered in the middle. I'm going to give you an example of that will happen in the future, right when the bell rings. You asked this question too, and I think we had one that was weird for a range, but a lot of times when you have two vertical asymptotes and a horizontal, it'll be up here, but then in the middle, it goes like this. Now, if that goes like this, what is the range right now? It's all real numbers. This portion right here covers all range value. That's the easiest question in the world then. The range is all real numbers. I don't care if I have a hole here. I don't care if I have a hole here. I don't think you could get two different holes. And I don't care about this horizontal asymptote. It's crossed right there. So that's an indication that would be all real numbers. So just do be aware of that. That could happen in rational functions. And actually, it did happen with my quiz with my A-Bers. All right, talking with Mrs. DeCare. Don't do those ones I crossed off. I still think there's a lot in the homework. Do the best you can. Try to get through them fast. Separate sheet of paper. Info, you don't have to letter it. I don't care about the letters. Just do your work to get it and then get the picture on the page. Got it? Especially on our homecoming week, and this is a special day.